Okay, so we're picking up where we left off with example 5. Okay, so notice that u is not given to you.
I can't find my notes.
I do not have extras. Okay, better write some stuff down. So we have to determine what u is. Now, some of these have little tricks to them that I would not expect you to know off the bat. But hopefully you can just follow the logic that I'm using. Because do you know anything that has derivative cotangent? Just plain cotangent?
Yeah.
You do? Yeah, I don't either. So what I'm going to do is change this. Using some trig identities, how else could I write cotangent? Cosine over sine or 1 over tangent. We're going to go with the cosine over sine. Okay, so these are kind of derivatives of each other, aren't they? We might need a negative in there for one of them. So we have to decide, do we want to let u be sine 7x or cosine 7x? Or maybe just the 7x. If I let u be cosine, then the derivative would be negative sine, which the negative is fine, we can deal with that. But it wouldn't be 1 over sine, would it? But the derivative of sine is just cosine. So I'm going to let u be the denominator. Okay. Now, the derivative, so du, will be cosine 7x times 7. All good with that? Okay. I look back over here. Oh, yes, there is a cosine 7x. There's not a coefficient of 7, so I can get rid of coefficients. That's easy. 1/7 du is the same as cosine 7x dx. Okay, so over here, this whole thing here will get replaced with that. All right, so rewriting this in terms of u, that would be 1 over u 1/7 du. Because this whole thing here is just replaced with 1/7 du. So think of this as 1 over sine 7x times cosine 7x dx. Can you picture that that's the same thing?
Could it also be du over sine?
Sure. Yep, I could put du up there. Sometimes you will see it now. Now we're going to do the antiderivative, which is what? Natural log of u. That's one of the rules that's on your sheet. Derivative of natural log x is 1 over x. Okay, but with logarithms, this, as well as the base, have to be positive. So just to ensure that it's positive, we'll usually put an absolute value around it. And then my last step is I will plug that back in.
Wait, why didn't we make the u absolute value?
One second. Okay, because logarithms are only defined for positive bases. The base is what's here, this base is e, except for 1. They can't be 1. So if I'm raising a positive number to any power, I'm only going to get a positive quantity. So that's why this quantity must also be positive. So just if we don't know what it is, we'll just stick it in absolute value, just as a reminder that this is going to be a positive quantity. Okay, so that would be my derivative there, or my antiderivative. Oh, and if you will look at, what if this was tangent instead of cotangent? Then I would use sine over cosine, and cosine would be the u value. On the back of your yellow sheet, you'll see tangent derivative, antiderivative is negative natural log cosine. Okay, so that's...
Make your u where their derivative would be the same as whatever else you have.
You're trying to figure out, and I'll be honest, sometimes I'll pick the wrong u, and you hit a dead end, and it just won't work, so you have to go back and say, okay, what else could u be equal to? Okay, example 6. Find the indefinite integrals. What does indefinite mean again?
No numbers.
No numbers are being plugged in. Yeah, I'm not going to get a numerical answer. In each case, you can use a trig identity to set up a substitution. Okay, so kind of like we talked about above, this is also the same as that. So sometimes instead of leaving the 1 in the numerator, they'll just put the dx or d whatever variable up top. So it might be helpful to think of it this way. I don't know of anything whose derivative is 1 over cosine squared, but what is 1 over cosine equal to? And what is 1 over cosine squared equal to? Oh. So this is really the same as secant squared. Does secant squared match up with anything derivative-wise? Tangent's derivative is secant squared. Okay, so let's still use a u here, because that's not just a plain old x, it's a 2x. Okay, so really there should have been a coefficient of 2 here, but there's not. But if I divide, I get 1/2 du equals dx. All right, so let's go back. I'm changing this in terms of u. That would be integral of secant squared u. I'm going to put the 1/2 out front, du. Okay, now antiderivative of secant squared u is tangent u. Let's see. Put the u back in. Tangent 2x. Let's see. Yes. They go away. And if I'm subbing in numbers, which we'll do in a minute, then we put that bar there. And the numbers go by the bar instead of the integral sign. Okay, so would you have known to do that? Maybe not, but can you follow it? Okay, so the next one will be kind of similar, like cosine cubed. Yeah, that's not the derivative of anything I'm familiar with. But we are going to break it down with a trig identity. First thing, I'm just going to say that cosine cubed is cosine squared times cosine. All right, next I'm going to replace cosine squared with a trig identity. Look on the board here. Remember that identity? Sine squared plus cosine squared is 1. So, yeah, I could replace cosine squared with 1 minus sine squared. Okay, now it might look like we made it worse because now we have a sine and a cosine, but remember that cosine is the derivative of sine. So perhaps this is there because of the chain rule, right? All right, so like I just said, cosine is the derivative of sine, so I'm going to let u be sine. And that's a good question. You don't always know. Like I said a minute ago, sometimes I'll run into dead ends that won't work, and so then you have to go back and try something else. But the more you do them, the easier it will get. Okay, du is just cosine x dx. And look, I don't have to do anything. All of that is there. So I'm going to replace cosine x dx with du. So this becomes the integral of 1 minus u squared du. Okay, I can take that antiderivative. What would it become? Antiderivative of 1 is, but we're using u. So u minus plus c. And then replacing it, sine x minus 1/3 sine x cubed plus c. Okay. Let me go back here. You don't need to write this down. But what if I had originally thought that this whole thing was u? We'll see what would happen. If I said u equals 1 minus sine squared x, then I would have to take that derivative, which would be 0 minus 2 sine times cosine. And that's nothing that's there. Okay, so that's not going to help me. I do have the cosine, but I don't have a sine being multiplied by all that. So that would be a dead end that would tell me, yeah, that's wrong. Okay. Yeah, and then where's the squared going to come in, and where's the 1 minus going to come in? Like it just wouldn't work. So sometimes we do choose things that just don't work, and we have to just try something else till we figure out what will work. Okay, now these are definite integrals. So notice we have some numbers that we're going to be subbing in. Okay, so same thing though, as far as antiderivative, like is something there because it's a derivative of something else? Secant squared is the derivative of tangent, isn't it? Okay, so what if u is just tangent x? Then du is equal to secant squared x dx. Okay, so I'm going to replace this with just du. And then this is just u. Yeah. So I just have the integral from 0 to pi over 3 of u du. What's the antiderivative of u?
U squared over 2.
U squared over 2, or 1/2 u squared. Whichever way you want to write that. And then, so I'm subbing in numbers. So the integral sign and the du go away. I put my vertical bar from 0 to pi over 3.
Why are we doing a u now? Because we don't know the antiderivative at first.
Right. Now, some of you might have been able to look at this and know. I think that one's a little tricky. Would we have known it was 1/2 tangent squared? Probably not. So, okay, there are two ways. Oh, back up 1 second. Why did I not do plus c?
Because you have numbers.
Okay, if you forget and do plus c, it's okay, it'll work out. Because if I did plus c, let me write this in pencil so I can erase it. Then I would say, okay, this is 1/2 u squared plus c, evaluated there, minus 1/2 u squared plus c, evaluated at the lower number, and then this c minus c is going to cancel every single time. So when we're plugging in numbers, we generally just skip the c part because it will cancel out. If you forget, that's okay, it'll cancel out. Just have one more thing to deal with until it cancels out. Okay, so here are two options. I'll work it both ways. First is probably what you would expect. I'm going to sub in tangent squared here. 1/2 tangent x squared from 0 to pi over 3. Which means 1/2 tangent pi over 3 squared minus 1/2 tangent 0 squared. Okay, where is pi over 3?
Right here.
Right here. Same as how many degrees?
1/2.
Same as 60.
1/2 square root of 3 over 2.
Hang on one sec.
Alright.
30, 45, 60. And the, would you say 1/2?
Square root of 3 over 2.
Comma square root of 3 over 2. Perfect. Okay, how do I find tangent?
Sine over cosine.
Or y over x, which becomes
Square root of 3.
2 square root of 3 over 2, which is just square root of 3. Okay, so let's come back down here. 1/2 tangent of pi over 3 is square root of 3 squared. Minus 1/2. 0 is right here. That ordered pair is 1, 0. If I do y divided by x, I get 0 squared. Okay, all that's 0. Square root of 3 squared is just 3.
And then you should get 1.5.
1/2 times 3, 3 over 2, or 1.5.
This is the area.
Yes, that would be the area under that curve between those two values. Okay, here's the other way that you can do this. I can take 1/2 u squared from 0 to pi over 3. And instead of subbing tangent in here, I can go ahead and find tangent of pi over 3 and tangent of 0, and then plug those answers in here. Okay, so this would be equal to 1/2 u squared from, what is tangent of 0?
0.
What is tangent of pi over 3?
Square root of 3.
Square root of 3. So I've already subbed it into tangent. Don't do it again. Now I'm just plugging in these numbers. And it'll work out the same way. So I have 1/2 square root of 3 squared minus 1/2 0 squared. And that gives me 1/2 times 3 minus 0, which is also 3 over 2. So at some point you're going to sub into tangent x. Either bring tangent x down here and then plug it in, or go ahead and plug these in now and then just use those answers here. Doesn't matter, you works out to be the same thing. Question? All right, one more. Let's take a look at that. Okay, my first question is, can I reduce this or split it up into x over x squared minus x over 4? Thank you. That's a no-go. Okay, that would be against all algebra rules that we've learned. That is a difference of 2 squares. I can factor it. Will that help reduce it? No. So that is a good thought. If there was like an x plus 2 up here, that's 100% what I would do. So that's not an option. Okay, what could we make u equal? X squared minus 4.
Is that just a guess? No, because the denominator.
Okay, du is 2x dx. Now you can see why this will work, hopefully. Here's your x dx. I don't have the 2, so we're going to divide by 2. And 1/2 du will replace x dx. Okay, so now this becomes the integral from 0 to 1 of 1 over u 1/2 du. Let that sink in. Are there any questions? Antiderivative of 1 over u? Natural log of u. 1/2 natural log of u from, 0 to 1. Okay, so we have two options. We can go ahead and plug this back in, then sub in 1 and 0, or plug 1 and 0 into here and use those answers. You like that? Okay. All right, so I'm going to come down here and say 1 squared minus 4 is negative 3. 0 squared minus 4 is negative 4. So now instead of going from 0 to 1, I'm going to go from negative 4 to negative 3 and not replace x squared minus 4 again. I've already dealt with it. Okay, so this becomes 1/2 natural log absolute value u from negative 4 to negative 3. Sub in the bigger number first. Subtract. Sub in the smaller number. So now I have 1/2 natural log 3 minus 1/2 natural log 4. Now if this is free response, we can stop there. But if it's multiple choice, I would guarantee that they're going to use some rules. I can do something with the 1/2, but what? I can factor it out first. Okay, now that's what I'll do. Okay, so I just factored out the 1/2. Now I have natural log 3 minus natural log 4. I can condense it using division. If it was plus, I would multiply them.
You do the first one always first.
First one goes on top. The positive one goes on top. Okay, so I could condense it to that. Oh, I could actually do something else. When you have a coefficient in front of a log, we can also bring it up as an exponent. And something raised to the 1/2 means any one of those are equal.
Wow.
And I'd be willing to bet that if an answer like
last
that
one?
was multiple choice, they'd probably go with that. So yeah, if you got this answer, you'd be like, what the heck? But those are actually equal.
Why is natural log 3 minus natural log 4 natural log 4?
Okay. Let me use some numbers like okay, let's look at this. So I'm not using natural log base E, I'm using a base 3. Okay, so if I said evaluate this, what that means is find that answer. So 3 raised to what power is 27? 3 cubed is 27. So this is equal to 3. The logarithm is really the exponent. Okay, so this is equal to what? 2. 3 minus 2 is 1. Okay, but if I use the condensing rule, this should be the same as log base 3 of 27 over 9, which is log base 3 of 3. And 3 to what power is 3? 1.
I didn't even know what log meant until you just did that.
Really?
What do log mean?
Logarithm is a really fancy way of writing the exponent of something. Okay? Got more for your money today.
If it was like negative
Learn
log
something new today.
327 plus log 399,
I didn't know what to do.
Then you switch them around. Yep. Okie doke. All right, so let's, you do have some problems in the textbook to tack on to that homework. And I have posted solutions on Google Classroom. So if you get stuck, consult those. But for right now, I want us to do a little practice with figuring out what U is. Okay, so while I'm handing these out, take a look at number 1.
Abby, I went to Soares yesterday. You did? Yeah, you weren't there. I keep telling you people I only work Mondays and Wednesdays. I thought they were closed on Mondays. That's not.
Woo!
They're closed lunch on Mondays. They're open general.
Okay, here we go. Here's one option. I could do this to solve number 1. I could multiply that 5 times and then distribute an x and then go term by term and take the antiderivative. Okay, that would take really a long time. I'm not interested in doing that, so I'm going to use U substitution. What should U equal? X squared minus 1. Why?
I know. It just seemed like it.
What's the derivative of that? 2x. Here's the x and the dx. I need to divide by 2 so that 1/2 du will replace x dx. So this and this will get replaced with 1/2 du. Okay, so rewriting it. U to the 5, 1/2 du. And then you can go from there. Right? Change that to 1/6 u to the 6. Multiply by the 1/2. Yeah, finish it all the way out. Uh-huh.
So 1/6.
Uh-huh. But you still have the 1/2. Don't forget to keep the 1/2. Y'all want to finish that one out? Okay, I'll finish it, but I'm not going to talk through it. Check when you're done. The more you do, the easier they will get. All right, so let's just pick a few here and there and just figure out together what U equals. And then I'll let you go back and finish working on them, because that's the key to it, figuring out what U is. All right, number 2, what would you, not a whole lot to choose from. What would U be? 3x minus 2. So du equals 3 dx. Leave it. Yeah, don't have a coefficient of 3 over here, so I'm going to get rid of it. Okay. Now, I'll let you come back and finish it. What would I use? Let's look at 5. What would I use for U? Number 5? 1 minus 4x cubed. Okay, and then du is negative 12x squared dx. See how we have that x squared in there? Yeah. Now, if I took the derivative and it didn't have a match over here, then that's a dead end. Try something else. Okie dokie. Let's pick you want to go ahead and set this one up? You'll have a hard time leaving one, don't you? Okay, so x squared in dx is going to be replaced by negative 1/12 and the du out there. So it's square root u du. Okay, so that's cool. But before I took the antiderivative, I would do what with it? Rewrite. Aren't y'all so good with fractions now? Like, you can just go back and forth, radical fraction, like, no problem. Ooh, more fractions to come, because when I take that antiderivative, it will be u to the what?
3, 2.
3 over 2. Oh, but we have to divide by 3 over 2. But when I divide by 3 over 2, it is the same as multiplying by 2 over 3. It is negative 2 over 36. That's a little bit fun, isn't it? If I were going to check it, I would have that coefficient. I would bring this exponent down and multiply. Subtract 1 from the exponent. Multiply by negative 12x squared. All right, turn that paper over. Yeah.
Plus one more.
Are we gonna get a grade for it?
You'll turn in homework tomorrow.
No. Are we gonna put this in?
We'll discuss.
I think we're
Should grade this? All right, fine.
No.
Fine, I'll grade it.
Nuh-uh.
completion.
Oh, now you're changing the story.
It's like homework. Wait, it's homework.
Not to these. I do not have the answers to these posted.
So you still want the grade?
Completion.
Okay, guys. Shh. Pick one.
12.
12? Okay, we'll start with 10, then we'll do 12. All right, what should u equal? Okay, so let's say, don't write this down. Let's say I use tangent 10x. What would du be?
10 secant tx. I mean, no.
I need a secant squared. That's not squared. Okay, that's a dead end. Tangent, secant, secant, tangent. We can write it either way. So, what you telling me? 10x. Because, like he said, tangent, secant, secant, tangent, that is a derivative of something. Of secant. So du is just 10 dx. I don't have a coefficient of 10. Okay, so how would I rewrite this?
110 tangent
Mm-hmm.
u secant
There you go.
u.
You get antiderivative, which is
No.
Look on your sheet.
Secant u plus c.
I'm not gonna have a sheet though.
That's what's got to be locked up here, Aiden.
I don't know how people do it without.
Well, you know sine and cosine derivative, right? You know tangent, we use that one a lot. What's tangent's derivative? Okay, what's cotangent? So you know what? If I were afraid I was going to need them, I would just jot them all down. Sure. Just like you could draw the unit circle, but I probably wouldn't waste my time doing it until I saw that I would need it.
Yeah, but then you forget about them.
Exactly.
Well, then write them down at the beginning of your test.
Cheat.
That's not cheating.
No,
That's
cheat.
doing a mental
Oh,
dump.
brain dump.
Yeah.
Oh, no. I'm at cheat.
Right
Oh.
on your shoe.
Okay, y'all go back
Yeah,
and
you're
put
right.
Change that
Well, but she
U.
was pretty